December mock 2023 Year 2 Applied paper continued. We are now looking at question 4, the first question of the applied section on projectiles. Given the initial paragraph, we can illustrate that the question is an object travelling upwards and then straight downwards towards a floor. There is no horizontal motion proposed by the question, but in order just to make the model look a bit nicer, I will simply spread the arc out like this so that we can see a bit more clearly the different sections of the function or what is going on. We are beginning from O, and I'm going to say that the landing point is A, and our first goal is to work out the height at which the object was projected above. In this case, since acceleration is constant throughout, we are able to utilize our SUVAT setup, and we are going to be using it to travel from location O to location A, with up as my positive indicated direction. Since up is my positive direction, my start velocity is the 39.2 provided piece of information, and my acceleration is negative g due to gravity. The trick here that some people will make mistakes on is that the displacement is negative h, since we are landing h units lower than where we started. In combination with the time being 10, we can utilize ut plus a half at squared is equal to s, the displacement taken, and we can substitute in our values and rearrange and solve for this value h. Typing the right hand side into my calculator gives 98, or negative 98, and therefore h is 98. The secondary question then asks us to investigate what is going on at certain speeds within the projection. The speed in this case can only be given by the vertical component of motion, since there is no horizontal component of motion, so we don't have to do any Pythagoras or consider any horizontal motion during the system. We do, however, need to consider the fact that because we are looking for the speed being lower than 24.5, we will need to be considering velocity in a positive and negative direction. So utilizing a SUVAT setup between those velocities, we are still starting at the 39.2, but our ending point for velocity is now either the upward 24.5 velocity or the downward 24.5 velocity. We will need to consider the time at which we hit both of these locations, or both of these velocities, I should say, in order to answer the question. Going back to the original diagram, the positive 24.5 will occur around about here on the left-hand side of the arc, whereas the negative 24.5 will occur over here on the right-hand side. Between those two X marked locations is when the velocity is going to be lowest, aka lower than the 24.5 desired by the question. Beyond those X units, either to the left of the first X or to the right of the second X, we will be traveling faster than 24.5. The slowest motions are the ones at the peak of the projection. So, given that it is the time that we're wanting to calculate from this set of equations, we will set up two SUVAT equations here, utilizing v equals u plus at, one using the 24.5 positive and one using the 24.5 negative. Both of these equations are extremely easy to rearrange and solve, so we should have no problem finding the values of t. In the first case, t is 3 over 2, and in the second case, t is 13 over 2. And as previously stated, the speed of the object is lower than 24.5 between these two instances, and therefore the time at which, or the time for which, we are traveling lower than a speed of 24.5 is the time between these two instances. So 13 over 2 minus 3 over 2, leading to 5 seconds worth of time interval.